right, so our next is we have a tag team presenter, Michael from University of Maryland and also Jason from Maryland DOT. They're going to tell us a little bit about a case study, kind of looking into the response time. So I'm going to, I assume, Michael, you're going to go first and then you're going to hand off to Jason. All right, go ahead.
All right. My name is Michael. I'm with the CAT Lab at the University of Maryland. I'm going to be talking about a tool that the university built called EventFlow, and Jason is going to walk us through a case study of using EventFlow. You know, our overview slide here. What is EventFlow? EventFlow for the transportation people is a really unfortunate name for this product because it takes two terms that we have pretty well established in the transportation sector and uses them in completely different ways. We are not talking about traffic events or flow rates or bottleneck conditions or anything like that. In EventFlow, it is a tool that was built using, it's meant to be generic, not just for the transportation sector. And so the team that built it was not thinking with the transportation sector particularly in mind. And so EventFlow refers more to discrete things that happen over a series of intervals. So what we think of as a traffic event in EventFlow terminology would be a record. And an event would be a thing that happens during the process of dealing with a traffic event. So notifying the state police, or shutting down a lane, or reopening the lanes, or posting messages on overhead message signs. Those are all the events that make up the records. So keep that terminology in mind. All right, so what is EventFlow? As I mentioned, it's a tool out of the University of Maryland, specifically the Human-Computer Interaction Lab. My group, the CAT Lab, works very closely with them. We have a lot of cross-collaboration. And it is a tool that allows you to look at a series of records, or in our specialized case, traffic events, and see where there are similarities between the events that make up those records, and can help you analyze trends. So let's say we have a traffic accident that happens on the roadway and some action is taken. That is an event. This is, say, calling the fire department. Another action occurs, that is, the fire department arrives. Another action occurs, the fire department shuts down a lane or two. And our last event would be the fire department leaving the scene. And so over the course of a day or a month or year or what have you, there are going to be many different accidents that occur on the roadway, and they're all going to have the same sort of events take place during them. You're going to have different agencies respond, you're going to have different lane closures, and you're going to have the lanes reopen, messages posted on your overhead message signs and that sort of thing. And we want to know what sort of trends there are across different events. And as I mentioned, this application was built to be a generic tool, so it has application outside of just the transportation sector. Its first use was actually for electronic health records. So you have someone who has been diagnosed with a certain condition. They check themselves into the ER. They're triaged a few hours later. They get admitted, or they get sent home. They get prescribed some medicine. The medicine runs out. They have a follow-up visit, that sort of information. And it was used to study mortality rates, essentially. You have student records. You have the course of a PhD student, or rather a set of PhD students, follow the classes they take, when they submit their proposals for their theses or their dissertations, when they do their defense, and so on, and web logs. So you log into a website, and then you may add something to your shopping cart, and then you may browse other products, or go directly to checkout, or start looking around for a coupon code or something like that. It can be useful for the people who run those sites to be able to analyze how they can more effectively turn visitors into buyers. But our usage is for traffic event logs using the types of events that I've already mentioned. So the University of Maryland has had tools that have been used in DOTs for several years now for analyzing things that happen within a single traffic event, a single incident. So this is our incident timeline. You might have seen this if you stopped by our booth earlier or in previous demos that we've given. It's got different sections. The top section there shows all of the messages sent back and forth between the different operators. The second section shows the notifications to different agencies or different units and when they arrived on scene. That middle section there shows when lanes were open and closed. The fourth section there shows the overhead message signs. If you mouse over any of those little gray bars, you can see what was posted on those signs at a given time. And then the bottom section shows the speed reading. So you have a contour plot showing how the queue progressed behind the incident location and eventually cleared from the roadway. Zooming in a little bit so you can see that a little bit better. In the screenshot, I've moused over this one bar here, and this represents the time when the state police was on scene. They arrived at the beginning of this bar at about 12:35, 12:36 according to the tooltip, and they stayed on scene until the incident was closed. That's what the green line at the right represents. At 2:43 p.m. and were there for 2 hours and 6 minutes. We can see the medevac helicopter was on scene only a short time, which is good practice. During the period when the medevac helicopter was on scene, they had the entire southbound side of this road closed, obviously so that that medevac could do its thing safely. Transcom got a notification. Each diamond is a notification. Transcom doesn't send units to a scene, but they get informed, so that's why that's not too surprising that we don't see a on-scene bar for them. And yeah, if I mouse over those gray bars at the bottom, I can see what was on DMS signs. So, that's very insightful stuff for that particular one traffic incident. It's good for an after-action review. But say you want to look at patterns in how your agency is dealing with accidents on the whole, and how can we improve, in the average case, not just in this one special case. That's where EventFlow comes in. So here's our little sample data set, and dropping that into EventFlow, what we have is a item in a list. Each one has an ID. With the events all entered here as they temporally occurred. Our y-axis is the events, our x-axis is time. So we're looking at about 4 months worth of data here, and we can see all of the different events that occurred. For this, it's a demo data set, so of course, ABC, nothing particularly meaningful, but when we get into the case study, I think you'll see how this can be applied more specifically to the domain. I can mouse over any one of these and click, tell me what the record is, and allow me to copy that ID. And so this is where it becomes really powerful. In the previous screen, it's kind of chaos. You can see, if you mouse over the particular record, it's really easy to see what the flow of events were that happened here. You had A, a little while later you had B, and a little while later you had C, but you don't really see any trends. Where you get to start to look at the trends is this alignment tool. So what we've done here is, instead of having the temporal axis represent time as we experience it in a calendar, we have time as it is experienced from the perspective of the event. So we've got all of the A's, all of the very first A's in our records aligned, and then however many days elapsed, and then the B, and then however many days elapsed, and then the C. So we can start to see trends in how long it's taking between A and B, and between B and C, or if after B, A happens again, and that sort of thing. And we can also align to B and see how much time preceded B when A happened, and that sort of thing. We have this graph that I've now docked here on the left next to my records that shows the entire data set. It's just condensed to fit within the screen space available here, so I don't have to deal with that scroll bar on the right, and I can see the trends more on a global level. So let's break this down a little bit. So each section here represents all of the records that have the same series of events. So the top section represents the ones that had A happen first, then B, and then C. And then down below you can see the most common sequences at the top, so your more irregular event patterns drift to the bottom. The height is proportional to the number of records, so we can see that there's maybe 25% that follow this A, B, A, C pattern than there are from the A, B, C pattern. And then the width here represents the average time between events. So I might be looking at dozens or hundreds of events that have this A, B, A, C pattern, but on average, we can see that this is the duration between my B and my C. If I mouse over on the vertical, I can see what the actual distribution looks like of the events that were taken up by that average. So here's my, that dotted line is representing what my average condition is, and the events that are represented with the bars on the left represent the ones that happened in less time than the average, and the ones to the right represent the events that took more time than the average. There's also a search feature, so I can go in here and I can look for events that have a certain pattern or a certain duration. I've set a filter for ones that have A and then C occurring in less than 2 hours of one another, and that can allow me to filter in on events that, I call the fire department and the fire department takes 20 minutes to get there. Is that acceptable or not? I want to look at all of them and see what other patterns occur for events where the fire department took more than 20 minutes to arrive. I can highlight matching records, and the views will be synced up so that the left view will also highlight the portions of the graph that refer to the selected items on the right. And that's kind of a brief overview of some of the abilities that the EventFlow tool provides. There's a little more to it than that. If you're interested in learning more about it, there's the website and the email address for Catherine Plaisant. She's the principal investigator on the project. So I'm going to turn over to Jason now, walk you through how this tool is actually used to get some insights into the fatal crash data.
All right, good morning, everyone. I'm Jason Dicembre. I'm the manager for Maryland State Highway Statewide Operations Center with CHART, our Traffic Incident Management Division of State Highway. And what we tried to accomplish here with the EventFlow tool was to figure out if there's a correlation between incident responders and why fatal collisions take so long to clear. Incident clearance is very important to us. The longer that incident stays out there, the more secondary collisions we're going to have, the greater impact to motorists and to user cost delay and everything like that. So why start with fatal crashes? The longest average clearance time tends to be fatal collisions, regardless of roadway, interstate, US route, Maryland route. And they involve more responders. So we have more data sets to look at for trends. And also, you might be wondering, well, I know this data must not be new to you. Why did you wait so long to do it? Our state highway uses a traffic management interface to input incident data in real time. So as incidents that are occurring on the roadway, we're getting phone calls from the state police, from our emergency traffic responders on the highway that are calling things in on the radio. And in real time, operators are entering that information into this advanced traffic management system. And they're tracking who's responding, who's been notified, who's arrived, what lanes are closed, what message signs are being used. Prior to 2014, some of the responder tags were ad hoc entries. So you could have a unit, we put our units in by call number, labeled as 9401, or someone could type them as chart unit 9401. And with the big push of data collection and making sure it's all accurate, we decided to basically remove operator decision, and it's now just a set of drop-downs to select from. So looking at only the Baltimore region in this particular case study, we had 219 fatal crashes between 2014 and 2016. I should note that these records are only from our traffic management software. They do not include state police data or local county jurisdictions that may not call us for every accident. And you may be wondering, they don't call you for fatal crashes. You'd be surprised. We do sometimes not get alerted. And Baltimore City does not report to the State Highway Administration because State Highway does not maintain any roads within the Baltimore City limits. So I'm only going to talk to the medical examiner today, but our initial case study focused on police investigation crash team and the medical examiner's office and their response. So using EventFlow, we were able to pull in all the 219 events between 2014 and 2016 to take a look at some trends here. Mean clearance time of 3 hours and 23 minutes from the time the incident starts to the time incidents are cleared. This is for all fatal crashes regardless of the responder. 16 records, if you notice, do not have a incident cleared. Inside of our system, the operator can mark the incident as confirmed, as cleared, and then they finally close the event. Scene cleared is meaning that all state highway personnel have cleared the scene. So in this case, what may have happened is either state highway personnel were not on the scene or they never called us to advise they were clearing before the police called to tell us the lanes were open. So this is breaking it down by jurisdiction, and why this is important to us is you can see the one long bar in Baltimore County really sticks out to us as why did this particular incident take so long? And that one took about 17 hours, I believe, to clear, and that was a huge mess. We can actually pull the incident ID that Michael showed you. We can highlight the event and pull it out and kind of get into some details. So if you notice in this chart, there surely was an increase in the average time from the incident to start for it to be cleared and closed as the years have gone on, going up to 4 hours and 33 minutes, which was disturbing to us. So we started looking at participants, and is there a correlation between medical examiners and responders? So taking a look at only the medical examiner, 114 records of the incident starting and no medical examiner notification. 39 of those do have the medical examiner as noting to be arrived. And in general, between the incident starting and the medical examiner being notified of those that we had the data for, it's about 36 minutes, and I'll talk about why that's important later. So from the time the incident starts to the time the medical examiner arrives, if you look at the far right-hand column of this table, it's pretty consistent. It's about 2 hours for the medical examiner to get on scene. So this is using EventFlow to take a look at the correlation between the incident starting, the medical examiner being notified, arrived, and departed. 76 records where no medical examiner was involved at all. Out of 219 events, that's a large piece of the data set with no record at all. What was interesting in this particular case study, we actually learned as much about our data as we did about the actual responders. So I mentioned it was all real time and being entered by operators. So we kind of leaned with our direction to the operators that no data is better than bad data. So if you don't know any information about when the medical examiner was notified or when they were called, don't enter it at all. So those 76 records were just those that we could not verify any of those times. So with this, we were able to go to the medical examiner's office and talk about why is it taking so long for them to be notified? Is it that the police are not calling them quickly enough? Or is there a flaw in their notification process with the police? And then once they're on scene, obviously they have some investigation to do. But we were able to actually talk to them with their issues that they have. It's not so much them being called that is the delay, but if you notice the time it took 2 hours for them to even get on the scene, they have to sit in the same traffic that the motoring public does. They don't have police vehicles. They don't have any emergency equipment. They are in private vehicles that have to travel the same way we would. So in talking with the state police or local jurisdictions, is there a way to get an escort for the medical examiner to get to the scene? Is there a way to get them certain authorized vehicles, even if state highway or local police have to help fund it? Is there a way to get them special dispensation to be able to ride shoulders or take special routes to get to the scene. We're able to go, though, with firm data to say that there actually is a problem with it taking 2 hours for a medical examiner to arrive on the scene. And again, this is not based upon it being simply overnight. This is an aggregate of all incidents regardless of time of day or route. So, and we could drill down further. And that was just, again, looking at the medical examiner's office for the sake of time. I am not going to talk about fire board and some of the other responders that we deal with. But you can see how being able to visualize it and see that the data segments helped us versus having to sort through 219 events, and that was just in Baltimore region. In 2016 alone, we entered over 110,000 event records. Over 25,000 of those were lane closure incidents. So some takeaways that we noted from looking at the data through EventFlow. One, that consistent, accurate, and timely data entry are critical. So you saw those 76 records with no entry at all. How do we fix that? We can't keep going with that limited data set. Better coordination and information flow between agencies. Right now, we're dependent on a phone call or the unit on scene telling us that the medical examiner has arrived or that they've been notified. So is there a way for us to integrate with the state police or local police CAD dispatch system so that we're getting true timestamps from the second the police call them, not just hoping that the unit on the scene is coordinating with the officer on the scene? The third bullet point, if I can say, to me was the wow moment. So in operations, we've always relied on planning departments to do studies for us, and those can take months. But as we're moving into this, I need to make real-time operational decisions based on data analysis. We need to make sure that operations staff know what tools are available to them. You know, whether it's EventFlow, whatever your DOT uses, if it's the RIDIS suite, whatever you have that your operations staff can use, make sure they know, A, that it's there, and B, how to use it. Because I can promise you that if they know it's there, they will use it. At least in Chart, I can tell you over the past 6 months alone, since being aware of all these different tools, we started to implement them to reanalyze patrol routes, to talk about where to position our staff and what days of the week need more patrolling. And lastly, that EventFlow can be a useful tool just to be able to visualize these segments of not just participants, like Michael said. You can do it by an incident in that event record being a lane closure. So is there a pattern between a particular incident type and how long it's taking to get the lanes open? Again, just looking at responders in this case, but some contact information for myself, Eileen Singleton with the Baltimore Metropolitan Council, who assisted with parsing the data and analyzing it, the EventFlow team from the University of Maryland. Thank you.
Thank you. So Michael.